Diconium approached me a few months ago and asking me, okay, Stephen, could you give a presentation here on stage? I thought for a few seconds, great opportunity to do a showcase about one successful AI application. But then I thought, maybe it's much better if I would talk about my, I don't know, more than 25 years of experience, what can go wrong when you try to build an AI application. And this is what I would like to talk about today. Maybe to start with, unfortunately, the bad news is 70% of all companies who invested into AI claim, unfortunately, there is no or just minimal impact of their AI applications. 70% of the companies. Even if you say companies who does severe investment, this number would just go down to 40%. So a lot of companies still struggling how to create value of AI applications. And the number that I find even more devastating is that 80% of all AI projects never get to be launched, never go live. I'm not sure how many of you are currently working on AI projects. I hope by the end of this presentation I can improve at least the expectation of your products going live slightly. So what are my most favorite pitfalls that you can run into, or what is the biggest problem I experienced in the past? And this is a misalignment of the AI solution with the business problem at hand. And it often starts at the data scientist side, where they start with an unclear business objective. To give you an example, long time ago, I'm not talking about what company that was, sales department approached our team and asking, could you build a predictor for the seasonal sales onset? So this when the sales goes up in spring or go up in fall, when you have the change of a season. And the data scientist thought about it. Prediction, check, sounds like data science. Sales data, it's quantifiable, amazing, yes, we can do. So they started getting the data, they got into it, they tried to apply some autoregressive methods, they tried to go deeper into it. Are there certain commodities that leading the sales of, in general, and are highly predictive? They collected weather data from all over Europe, from many, many weather stations, broke down the sales to these local areas around the weather station. And after spending a lot of efforts, they came up with a very good solution and said, hey, look, if the temperatures exceed 20 degrees and the sunshine duration exceeds more than 6 hours per day for 2 days in a row, this is when in spring the sales will increase, go through the roof. They went to the sales department, presented this, and then the sales department asked one question. Okay, are you able to predict this 3 to 4 weeks in advance? Because this is the lead time that it takes for us to set up our marketing campaigns, to bring in the staff in the warehouse so that they can process all the orders. And this was the moment when the data scientists realized, well, maybe we can't. We can't beat the weather forecast. And from the data science perspective, it was an interesting exercise. Did it create value to the business? No. So that's why before you start looking at any data, first of all, you have to create this deep understanding of what is the problem that you want to solve. You need to understand how the business process works end to end. You need to identify what are your levers that you can influence with your data science solution. And also how value will be created out of this solution. And last but not least, you should also have the answer to how will this solution be operated in the future. These might be all questions that on the long term lead to be not successful. And if you have the answers to all of these questions, then you should also step back and ask yourself, why should this be solved with AI or machine learning? And if you have checks to all of these 4, then you should sit together with the business unit and really clarify what are the expectations, what are the exact goals, what is the success criteria of the project, and then you can start getting your hands dirty on the data. Also, still part of misalignment, how to measure success. I once joined a company where when I joined, they launched an A/B test 3 months ago, with 3 different versions for different onboarding funnels for customers. And interestingly, when I came, they couldn't agree which one was the winner. You spoke to the marketing team, they said, well, clearly version A is the winner. It has the best conversion rate, it's maximizing our marketing efficiency. The sales department said, no, clearly version B. Highest average basket size, great. Then there came a different department that took into consideration also the cost, said, no, version A, version B are way too costly, so it's clearly version C. So when I joined, I was asked, Stephen, could you help to identify who is the winner? And by the way, keep in mind, if you have 3 winners, you could also look at it differently. You have 6 losers. So everyone was a loser. So what we finally did is we agreed upon a cost-income ratio as the KPI, the cost side as the marketing spend. On the income side, we took a customer lifetime value over 12 months. And this was a measure everyone could commit to. And don't know, let's say it was version B that finally won. What does it tell us? If you're running a data science project and you cannot agree on how do we measure success, it might be that you have a very successful data science application, but no one will find out because you're measuring it the wrong way. So therefore, when you start, you should also align your success KPI with all potentially impacted stakeholders. And in case they cannot agree, maybe reach out to the controlling function. They might help you to mitigate, or as a mediator between all the different parties, because they usually have the best view on the overall profitability or whatever of a company. The second thing, and this is really a must-have, you should, whenever possible, launch your AI application via an A/B test. It's not nice to have, it's a must-have. It allows you to really prove black or white on white what is the impact. But secondly, it also helps you to protect your application by some people who claim, well, when you launch your application, the return rate went up. The customer service rate went up. Might be just a correlation, or an accidentally correlation, but it could also be a causal effect. Having launched things via A/B test would allow you to prove people right or wrong, or quantify these what I would call collateral effects. So A/B tests are a must-have. When it comes to the success KPI, you should always go for macroscopic business KPIs. Ideally, if possible, get as close as possible to the North Star of the company. Really don't use any local, like, oh, we improved the click-through rate KPIs, or any other technical metric, like, oh, the area under the curve improved by 10%. Because you need to convince the business side, especially you should be recognized by also the CFO, because these are the person who in the end will make the decision, was this a good, successful application? Will I invest further into this? So that's why I go for macroscopic business KPIs. Same when it comes to defining the objective function for your model optimization. Stay as close as possible to business KPIs. You should have a good understanding of what are the costs of true positive, false positives, and so on. Measuring success. Lack of collaboration. Data science is a team sport. You can't run data science in isolation. It involves data scientists, it involves data engineers. If you want to bring things integrate into a product, you need software engineers, you need product managers, you need people for the operations, MLOps, DevOps, analytics to evaluate all the things that you create, and of course the business side. So it's a team sport. If someone doesn't or isn't part of your team, you're most likely set up to fail. Therefore, before you start, especially with larger initiatives, you should get the buy-in of a cross-functional leadership team from the product side, from the engineering side, from the data side, and of course, the business owner. And if it's really a large initiative, also try to get the C-level as a sponsor who is able to pave you the way to remove blockers across the org. If you don't have this backup, you might bounce in the organization. Similarly, sometimes people ask me, Stephen, how do you manage to bring things into production? We often bounce on the product management team. I said, well, there's only one trick to it. Make data science part of the product roadmap. Ideally, you could also have a reporting line of data science into product. Yeah, so I have very good experience with that. If not, there is a fair chance that you don't not be able to deploy your things into production. And finally, of course, when it comes to the execution, you need to have a good framework in place that allows you to secure the necessary resources. Yeah? From business, from product, from engineering, from data science. Ideally, in a company that runs an OKR framework, this should be easy. Yeah, but nevertheless, you need to have the commitment from all the departments to contribute. This one is a bit tricky. Lack of talent or hiring the wrong team. I think we all know this Venn diagram by Drew Conway, right? What makes a good data scientist? You need to have excellent coding skills, deep knowledge in mathematics, statistics, and a very strong business acumen. I think what makes things a bit more complicated nowadays is that everyone calls themselves a data scientist. Yeah, people who are doing fancy stuff with Excel, but using data, calling them data scientists. People working in the analytics domain also call themselves data scientists. Makes it a bit hard to distinguish what kind of data scientist are you currently talking to. So, and I think what makes things even worse is these script kiddies, yeah, that are now new at the block, that have a good understanding how to use certain library, but don't have this real understanding what does it mean, what they are applying. Yeah? So that's why when you hire and you don't find highly experienced people, you could still go hire for potential, hire for a growth mindset, but do not sacrifice any of the necessary skills. If you hire someone without business acumen, you will end up with a nerdy solution. Yeah, and if they can't code, probably things will not go to production or will break in production. Then I think there are two core roles in your team. Let me start from the bottom, yeah, the team lead. I think this is really the most crucial role in your data science team. This person needs to be a jack of all trades, because this person needs to provide guidance to all the other collaborators, to the engineering team, to the product management. This is the person who needs to talk to the business side to talk about what are the limitations of AI or what are the abilities, and of course provide strong guidance to your data science team. Yeah, so if you focus on one position, it should be the team lead position. One position where I still struggle a little bit with is the position of a data science product manager. I think this is really a unicorn. When you come from classical product management, here you have a strong focus on the customer, yeah, to create the best customer experience. You understand the business side. You translate this all into requirements for your engineers, and then you help the engineers to manage, you define your acceptance criteria. What makes it so challenging to move into the data science space is that your product is not just supposed to create the best customer experience. You need to design the product also with the algorithm in mind. You need to create a product that is enabling or creating an environment for the algorithm to continuously learn. Yeah, so that at some point your algorithmic quality improves until you can unlock the next product features. And this needs to be included by design. And this requires a deep understanding, in my opinion, of data science. And so far I met one or two people where I say amazing data science product manager, so that's why I would really call them a unicorn. And in case that you can't find any, what you should have at least in your company is a data strategist, someone who really helps to set the vision for the different products and how the AI could help to improve. Poor data quality and quantity. I think we talked about this several times. You may wonder, why does it come so lately? Yeah, so this is number 4. Yeah? And I think the reason is data scientists are also data artists. Yeah, they are not spending these 80% of their time just for fun. They are really trying to turning something into gold, let's put it that way. And yeah, that's why I think some of the mistakes that happened in the past with the data, low quality, they can try to fix. Of course, it's very costly, but at least this isn't really killing your product. Of course, there are a few things that might limit the applicability of your product. Yeah, for instance, if you are not able to construct historical information. I mean, data science is all about understand the past to predict the future. If you can't replicate the past or reconstruct the past, how can you predict the future? Yeah, and this is also something that data scientists can't fix. Or similar, if you have missing data. I once worked for a company where they decided, let's only store 50% of the customer journeys, for 50% of their customers. And then they approached the team and can you build a personalization of the customer journey based on that data? The answer is yes, the data are sufficient. Yeah, one could build it. But unfortunately, how shall we then roll it out to 100% of the customer if for 50% of the customer we don't have the data? So yeah, a few things you can't fix. And unfortunately, you also can't fix it on a short term. Yeah, so we heard about Zalando, 10 years of fixing the data and still ongoing endeavor. Yeah, so that's why when you start your data science activities, I think that should be also the same moment when you start your data, implementing your data strategy, start thinking at least about the data governance strategy. And this should be mainly also driven by the requirements coming from data science. Breaking data silos. I mean, data scientists take data from everywhere. Yeah, in the offline world, I think here great progress was made over the past decades, bringing data together in data lakes, data lake houses, everything. Unfortunately, for the data science application, if you want to run things in production, it also requires that you have the same capabilities in real time. You need to have the data from the website. You need to have the data from customer service available maybe in real time, so that you could run your AI application successful. One way to mitigate this potentially might be feature stores. They would also help you with this mismatch of the offline world, where data scientists spend a lot of effort in reconstructing the historical data. And once they see real-world data in the online or in the production environment, there's a mismatch. Feature stores might be one way how to mitigate it. My last slide. Let's assume you were successful in launching your first AI application. So first of all, congratulations. But be aware, now comes the even more challenging part. You want to maintain the impact of your application. Yeah, or maybe you want to scale across the company. You want to have AI everywhere. And here you should be really aware this is costly. So first of all, when you introduce AI in your product environment, it increases the complexity of your product. Let's just assume we would have personalized customer journey. We have several touch points. Everywhere is an independent algorithm running, making the decision if the customer should go left, right, straight. If you have several touch points, it's exponentially growing, the number of customer journeys. And unfortunately, each touch point makes a different decision. Yeah? Sometimes customer is sent left, sometimes it's right. It is hard to reconstruct what are the properties of a customer that determines exactly this journey. In the past, you had maybe personas used for designing customer journeys. Now you have these weird algorithms that making the decision, and you don't know exactly what are the properties that determining what journey the customer will take. Another thing, the data dependency that you create between all of your applications. You have an AI application, it takes the data from everywhere, you create a lot of dependencies. Sometimes the dependency are explicit. Also in the past decades, engineering spent a lot of effort in designing microservices, having an API-first strategy, defining the API as the contract between the two parties. As long as you do not change the API, things shouldn't break. With data science, things might be different. Even if the API is stable, it might be that the underlying assumptions behind the data change. To give you a very quick example, let's assume you want to build a fraud detection system. And one of the features you want to use is the engagement of the customer on the website. So only thing that you need is, let's say, the timestamp, when did the session start, the web session start, and when did the customer show up in the checkout. So the API just requires, please send me when did the session start. So now let's assume other product teams are working on, okay, let's have a one-click checkout feature, or making smarter recommendation to limit the number of page views. Still, the API is stable, you're still getting the time when the customer started the session, but the duration changed. So this also the meaning of the data that you create or the feature changes. And this dependency might even lead to something which I call here product feature lock-in, that you are no longer able to change your product because it's providing input to your AI system that is really optimizing things, driving things into a local minimum. If you do slight changes, it might be that the overall product experience improve. But the impact of the AI might easily get lost so that the net impact might be negative. And then you are locked into such a situation. And here product also needs to be aware of this. And things that are linked to it, cost of maintenance, you have feature drift, changing data, you permanently need to adjust your algorithms, you need to retrain your AI applications. Before or after the training is before the training. If you want to scale, you need to heavily invest also in infrastructure. You need to be able to do ML ops at scale, train models at scale, be able to have CI/CD pipelines, have monitoring solutions in place. This is also a heavy investment. And last but not least, the cost of implementing a data strategy across the entire organization. It's very expensive. 10 years at Zalando, but still, you also have to get the commitment, the full buy-in of the engineering, the teams, because these are the producer of the data. This is really a costly investment, and you should be aware of this before you really say, hey, AI is the future of our company. And with that, I open the floor for questions.